Have you ever wondered if an AI could get so smart that it could, fix its own mistakes? Well, today we're diving into some really cool research that explores just that. We're looking at how one AI can actually clean up another AI's messy work to create a perfect plan. Okay, let's get into it.
All right, to get what we're talking about, picture this. You're following a recipe, and it tells you to preheat the oven, then turn it off, and then preheat it again. It's not just confusing, right? It wastes your time, wastes energy, and it just feels completely wrong. You wouldn't just follow it blindly, you'd take a pen and cross out those useless steps.
Well, it turns out that when we ask an AI to generate a plan, say for a robot in a warehouse or something, it often spits out instructions with that exact same kind of clutter. So today, we're exploring a breakthrough method for taking one of these messy, inefficient AI plans and polishing it until it's absolutely perfect.
So first, let's really get a handle on the problem itself. What does this clutter actually look like inside an AI's instruction manual? That useless preheat then turn off step? Well, there's a technical term for it, a redundant action. Simply put, it's any instruction in a sequence that you can just get rid of and you'll still get to the same goal. It is pure 100% waste.
And look, this isn't just some academic nitpick. For a real robot navigating a factory or a logistics network routing trucks, these extra steps translate directly into wasted time, more fuel burned, higher costs, and honestly, just a much greater chance for something to go wrong. Cleaning up these plans isn't about being tidy, it's absolutely essential for efficiency.
This whole problem has sent researchers on a kind of quest. A quest for the perfect, most streamlined plan possible. But as you can probably guess, finding that perfect plan, it's nowhere near as simple as it sounds. The holy grail here, the thing everyone's after, is what's called a minimal reduction. Now, this isn't just a shorter plan. We're talking about the absolute shortest, most efficient, most elegant solution you can possibly find. Not a single wasted motion.
But here's the catch. Finding this perfect plan is what computer scientists call an NP-complete problem. Now, you don't need to be a math whiz to get this. Just know that it's basically code for incredibly mind-bogglingly difficult. As the number of steps in a plan grows, the number of possible combinations to check for junk just explodes, making it totally impossible to solve by just trying everything.
So, how in the world do you solve a problem that hard? Well, the researchers behind this paper came up with an idea that's just beautifully clever and maybe a little counterintuitive. Instead of trying to build some crazy new tool from scratch, they asked a simple question. What if we use a standard, off-the-shelf AI planner to fix the plan from another AI planner? The real genius here is taking a tool that's designed to create plans from nothing and turning it into a super efficient editor. It's literally AI perfecting AI.
And the most effective way they found to do this is so simple and intuitive. The second planner just goes through the original, messy plan one action at a time. And for each step, it makes a simple decision. Do I keep it or do I skip it? And by making this single best choice at every single step, it builds that new perfect plan from the ground up. Now, even with that clever setup, checking every single step can still be a ton of work. So the researchers added a kind of secret weapon to make the whole process dramatically faster.
They focused on identifying something called Plan Action Landmarks, or PALs. The best way to think about these is like the load-bearing walls of a building. They are the absolute must-do, non-negotiable steps. If you take even one of them out, the whole plan just comes crashing down.
Now, this is where it gets really interesting. Just look at how common these essential steps are. The research found that on average, a whopping 85% of actions in any given AI plan are these essential landmarks. That means only a tiny slice, about 15% of the plan, is even potentially junk. And that right there is the brilliant strategy. By finding that core 85% of essential actions right at the start, the planner can basically lock them in and not waste any time thinking about them. Then it can focus all of its brain power on that much smaller 15% slice, figuring out which of those few remaining steps can finally be thrown out. So we have this new, clever method that seems super efficient. But the real question is always the same. How does it actually stack up against the reigning champion, the previous best technique out there? Okay, so in one corner, we have our challenger, the new planner to fix a planner approach. And in the other corner, the champion, a method called WP Max Set. Now, all you really need to know about that one is that it's a very powerful, but also very complex system that works by turning the problem into this giant web of logical rules.
And the results from their head-to-head showdown are in, and it's pretty clear. The new classical planning approach is the winner. It solves just a few more tasks overall, sure, but it's generally faster. And, this is the really important part, it totally nails the super tough problems where the old method just gives up and crashes.
For instance, the researchers designed this really nasty test, a logistics problem with complicated fuel management. For the old method, the complexity just exploded, and it literally ran out of memory. But the new method, because its logic stays clean and simple, it solved it, no problem. This shows it isn't just faster, it's fundamentally more robust.
Okay, so this is a huge win for computer science, no doubt. But what does it actually mean for the rest of us? Why should we really care about a more elegant AI plan?
Well, it matters because better plans have a massive real-world impact. This isn't just theory. This leads directly to warehouse robots that complete their tasks faster, delivery trucks that use less fuel, and manufacturing processes that waste far less time and energy. It's about turning that computational elegance into real, tangible savings out in the world. And all of this leaves us with a pretty fascinating thought. We've just seen how AI can be repurposed to refine and perfect its own logic, to literally make itself better. So the big question is, what's next? What other complex skill that we thought only humans could do will we soon see AI teaching itself to master?